students, we discussed in a last class the topic is, so what is the, so that means the dipole is placed in the uniform electrical field, so that to find out the potential energy, so U is equal to, okay, PE cos theta, okay, minus P dot E cos theta, okay. So last class that topic already discussed. Now today so discussed another topic, that is called as a, what is the capacitors and what is the condensers. And so the capacitors are connected in a series combination and the capacitors are connected in a parallel combination. What is the effective capacitance? What is the effective capacitance in series combination and parallel combination? Now, first of all, discussed about the topic is capacitor and condenser. Okay, same meaning. What is the meaning of the capacitor? Is equal to the condenser. So, meaning of the capacitor. So, the capacitor is called the energy storage device. The capacitor is called energy storage device. Okay, capacitor. So, capacitor means energy stored device. అంటే దట్ మీనింగ్ ఇస్ ద ఎనర్జీని, శక్తిని స్టోర్ చేసుకుంటుంది. ఓకేనా? సో మనకు ఫ్యాన్ పైన కండెన్సర్ ఉంటుంది, ట్యూబ్ లైట్ పైన కండెన్సర్ ఉంటుంది. ఓకే, సో ఒక మోటార్ పైన కూడా మనం కండెన్సర్ని అబ్జర్వ్ చేయొచ్చు, సిలిండర్ షేప్. ఓకే, సో సిలిండర్ షేప్లో మనం అబ్జర్వ్ చేస్తున్నాం కండెన్సర్. సో వాట్ యూజ్ ఆఫ్ ది కండెన్సర్? దట్ ఈస్ ద ఎనర్జీ స్టోర్ డివైస్. ఎనర్జీ స్టోర్ డివైస్ అంటే సో ఎంతో కొంత శక్తిని తన దగ్గర స్టోర్ చేసుకుంటుంది, ఎనర్జీని స్టోర్ చేసుకుంటుంది. దట్ ఈస్ కాల్డ్ యాజ్ ఏ కెపాసిటర్. గోట్ ఇట్? సో జనరల్ ఫర్ ఎగ్జాంపుల్ is taken, so that is called as a beaker or so any one of the material. The water is stored is depending upon the, okay, so depending upon the only shape and size of the container. You got it? So for example, so the water is stored in a bucket or water is stored in a beaker. Okay, so depending on the shape of the container, size and shape of the container, size and shape of the container is converting. Now similar pattern here also like that. That is, so the energy is stored depending on the device. So now for example, the condenser is taken, that is the conductor is taken. So this is called as a conductor. Okay, got it? Conductor. The charge is increased on a conductor gradually. Okay, the charge is increased on a conductor gradually. Also increasing of the potential difference. Okay, also increasing of the potential difference at any instant of time. At any instant of time, the charge is, okay, the charge is directly proportional potential difference. Okay, at any instant of time, the charge is increased on a conductor. The potential difference is also increasing on a conductor. At any particular instant of time, the relation is directly proportional. Okay, the relation is directly proportional. That means Q is directly proportional V. Okay, and so the proportional is taken neglected, so some constant are taken, so that is called as a C into V. So C is equal to Q Q by V also we can write. So C is called as the proportionality constant, that is also called as a capacitancy of capacitor. Capacitancy of a capacitor. Okay, got it? So C is called as a capacitancy of a capacitor. So what mean of the capacitancy of the capacitor? So C is equal to Q by V. Q is means charge, V is means potential difference. So the ratio between the charge to the potential difference of a conductor is called as a capacitancy. Capacitancy, very important formula. C is equal to Q by V. We can write. That is means the difference between the ratio between charge to potential difference is called as a capacitancy of a capacitor. Okay, got it? So units are measured in farad. Okay, farad. So yes, this is measure farad. Farad. So 1 coulomb of the charge and 1 potential difference 1 volt. Okay, 1 coulomb of the charge, 1 volt is called as a farad is taken. That is called as a capacitancy of the units. Got it? So C is equal to Q by V. So the capacitors are symbolic representation of the capacitor. So this is called as a parallel plate. Parallel plate. So this is called as a first plate is taken positive and the second plate is taken negative. So C is called as a capacitancy of the capacitor. Okay, got it? So the symbolic representation of the capacitor. So this is called as a two plates are parallel. That is called as a positive plate and a negative plate. Positive plate and a negative plate. Okay, got it. So also the symmetrically represented. So this also capacitor. Okay. So the capacitor is depending on the nature and so the material. Okay. So etc. size and shape also. Okay. So now the capacitors are connected in a series combination. What is the effective capacitancy? That means so the capacitors are connected in a series combination. What is the effective capacitancy? Effective capacitancy or resultant capacitancy. Now first of all here observe the capacitors are connected in a series. Okay, the capacitors are connected in a series combination. So the arrangement of the capacitor as shown in this circuit diagram. Okay, the circuit diagram of the capacitors are arranged in a series combination. Okay, got it. So now here taken only the 3 capacitors. Only 3 capacitor is taken. So the 3 capacitors are connected in a series combination. Okay, so series combination. So the first of all, the arrangement in a series combination. Now here see that. So first plate and second plate, first plate, second plate, first plate, second plate. So the second plate of the first capacitor is connected to the second capacitor first plate. And the second capacitor, second plate is connected to the third capacitor, first plate. third capacitor, first plate, and so on. First capacitor, first plate. Last capacitor, second plate is connected through the opposite terminals of the battery. Opposite terminals of the battery. So that the arrangement is called as a series combination. Okay, the arrangement is called as a series combination. In this series combination, so the arrangement, so look here. So this is called as a second plate of the first capacitor is connected to the second plate of the first capacitor, and second plate of the second capacitor is connected to the first plate of the third capacitor, and so on connecting. So first plate of the first capacitor and last plate of the last capacitor of the second plate is connected to the opposite terminals of the battery. Opposite terminals of the battery in circuit combination. Okay, circuit. In series combination, the charge is drawn from the battery. The charge is drawn from the battery is through in a single direction. In a single direction. That means the charge is appears on each capacitor is equal or same on capacitors. Okay, got it? బ్యాటరీ నుంచి మనం ఛార్జ్ డ్రా చేస్తున్నాం. మనం డ్రా చేసినటువంటి ఛార్జ్ అనేది ఎట్లా పోతుంది సార్ అంటే ఓన్లీ సింగిల్ డైరెక్షన్ పోతుంది, ఓన్లీ ఒకటే వేలో వెళ్తుంది. కాబట్టి ఇక్కడ ప్రతి కెపాసిటర్ మీద కూడా ఛార్జ్ అనేది ఈక్వల్ గా ఉంటుంది, సమానంగా ఉంటుంది, సమానంగా వితరణ చెంది ఉంటుంది అని చెప్తాను. అలాగే పొటెన్షియల్ డిఫరెన్స్ అనేది ఈ కెపాసిటర్ మధ్యలో ఈ కెపాసిటర్ మధ్యలో ఈ కెపాసిటర్ మధ్యలో డిఫరెంట్ గా ఉంటుంది. That is means so the V1 and V2 and V3 are capacitors potential difference. Okay, so the potential difference of the capacitors V1 and V2 and V3, capacitance of the capacitors C1 and C2 and C3. Okay, got it? So the capacitance of the capacitor C1 and C2 and C3 and potential difference V1 and V2 and V3. Okay, the charge is appears on each side, but potential difference is different. Okay, potential difference is different. That means V1 and V2 and V3 etc. is taken. Now the total potential difference from circuit diagram. From circuit diagram, V is equal to V1 plus V2 plus V3 గా మనం ఐడెంటిఫై చేస్తున్నాం. Okay, so V is equal to V1 plus V2 plus V3 is the total potential difference from the circuit diagram. Okay, got it? So already, so the capacitance equation C is equal to Q by V. Capacitor capacitance equation or formula C is equal to Q by V. Okay, got it? So C is equal to Q by V, but here V is equal to Q by C right hand. We can write. Got it? So V1 is equal to Q by C1 and V2 is equal Q by C2 and V3 is equal Q by C3. Okay, so these are equations are substituting in equation 1. Equation 1. We get Q by C is equal to Q by C1 plus Q by C2 plus Q by C3. Okay. So the common is taken Q by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 into Q. So Q are cancelled. So remaining equation we get 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is called as a resultant capacitance in series combination. The resultant capacitance in a series combination, that is 1 by C is equal 1 by C1 plus 1 by C2 plus 1 by C3. Okay, got it? Now, if in case of number of capacitors are connected in a series combination, number of capacitors are connected in a series combination, the effective capacitance we can write. So 1 by C is equal 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. 1 by Cn. Okay, this is called as a number of capacitors are connected in a series combination. The effective capacitance is 1 by C is equal 1 by C1 plus 1 by C2 plus 1 by C3 etc. 1 by Cn we can write. Got it? So the capacitors are arranged in a series combination and we can find the effective capacitance in a series combination. Okay, right. Also, find out the capacitors connected in a parallel combination. Okay. So, what is the parallel combination and how to be connected in a parallel combination and to find out the effective capacitance or resultant capacitance in a parallel combination. Okay, got it? Right. So the parallel combination. So first of all, we observe the circuit diagram. Okay, now here observe the capacitors are connected in a parallel combination. Parallel combination. So how to connect it in a parallel combination? So the first of all, so this is called as the first capacitor and second capacitor and third capacitor. Okay, so the first capacitor first plate and second capacitor first plate and third capacitor first plate. Okay, so these are first plates are connected single terminal or one terminal. Okay, got it? And so the second plate of the each capacitor, the second plate of the each capacitor is connected to the another terminal. These two terminals are connected to the opposite terminals of the battery. Got it? So first of all, the arrangement in a parallel combination. Okay, the capacitors are arrangement in a parallel combination. So these are first plates of the all capacitors are connected one terminal. The second plate of the all capacitor is connected to the another terminal. These two terminals are connected to opposite of the battery. Okay, that is called as a parallel combination. Okay, in this parallel combination, so C1 and C2 and C3 are capacitance of the capacitor, and so the potential difference crossing through the battery is V as shown in this figure or circuit diagram. Okay, so the potential difference on each capacitor is equal, but the change in A are not equal charge. The charge is divided Q1, Q2, Q3 at one point. Okay, but potential difference on each capacitor is equal. Okay, the potential difference on each capacitor is equal. The charge is different, but the charge is different. The total charge Q is equal to Q1 plus Q2 plus Q3 from circuit diagram. You got it? So V is equal to Q by C. V is equal to Q by C, or C is equal to Q by V. We can write the capacitance, capacitor formula. C is equal to Q by V. So Q is equal to, we can write CV. Q1 is equal to C1V. Q2 is equal to C2V. Q3 is equal to C3V. Or substituting in equation. Okay, so Q is equal to CV1 or C1V plus C2V plus C3V. So common is taken V. So C1 plus C2 plus C3 taken common is V. So V are cancelled. So remaining equation we get C is equal C1 plus C2 plus C3. So this is called as a resultant capacitance in parallel combination. Now, so the capacitors are connected number of. Okay, so the effective capacitance or resultant capacitance we can write in mathematical. So C is equal C1 plus C2 plus C3 etc. Cn. So this is called as a resultant capacitance in a parallel combination. Got it? Okay. So now discuss the another topic next class.